Hello everyone, welcome back to my channel. If you want to join my stream, get up a good close, you can just join up by using the QR code. You can rewind if you want. Thank you. We will begin in momentarily after getting things like Okay, hello everyone, welcome back to Game Stream Nation channel. In today's video, we'll be going up about maths NGS presentation part 2. I hope you're all doing very good. Okay, without further ado, let's get this started, shall we? Okay, now. Okay, so as I share my screen, so I'll show my screen in a second. So I hope you have seen the last video about where I talked about my Scotch and the new website. Alright, so hope you have gone through it. It's almost time. Okay. Anyway, Shukil, let's get started, shall we? For 1 second. I have to open it in my. It's just there, I have to open it. And whoever, I mean, it has to be someone's birthday every day, right? So whoever birthday is it's today, happy birthday from me. Happy birthday. Okay, shall we get started now? Let's just do this. So, I hope you can see my screen. If you want to join my Discord server, the code is right up here. And if you want to join, and if you want to subscribe, the link is up here. Now we start off your module 2 official. Okay. I feel like this is I think it's because I'm right? Man, it's really hard to use. Oh, what's too loud? Let's try. Can you guys still hear me? I don't know if you guys can still hear me. Oh, wait, 1 second. I need to start this. Uh, Let me just sort this out. Okay, 1 second. 1 second. I know I have limited time. 10 minutes already almost gone here. So I was gonna mute the site for a second. Okay, sorry, I'm back now. Okay, you guys can hear. To keep it to exactly 10. Shall I? No, I'll keep it at 7 or 5. Keep it 5. Okay. Okay, sorry about the long wait. Okay, now. Okay, okay, sorry for the small wait. Okay, let's get back. Okay, now where was I? Yes. Now we're going to be moving officially on to exponents and powers. Okay, starting off with the content. Firstly, we have the introduction to powers, followed by the laws of exponents, followed by negative and fractional exponents, followed by the scientific notation, and also a test regarding this. So keep in mind. So what is a law of exponent? So whenever we have a variable which contain exponents and they also have equal bases, meaning this here, see. Okay, let me give an example. Suppose you have 2 power 2 and 2 power 3. So you have the same base here and here. So, so you can highlight it here. So it says whenever we have a variable which contain exponents and have equal bases. So one thing to remember, equal bases, very important. Equal bases and contain exponents. They have to contain exponents. It's not even called this. It's not even this. Okay, it doesn't follow it. It has to have base or the exponent slash power. They call it exponent or power. It's the same thing. Okay, they have to have an exponent. I think I use this part. They have to contain. Oh, sorry. Man, I really suck at this. They have to contain exponents here. See? Okay, they have to contain exponents other than. If they don't, man, you're cooked. So you can do certain mathematical operations to them. That is what we call the laws of exponents here. Okay? The laws of exponents. Alright? So hope you have understood. Now I'll give like a small example before we move forward. So when we say here equal bases which contain exponents, let's look at this here. Okay, let's look at this here. So the general formula for an exponent is base with an x, which is called the exponent, or p for power. Okay, let's write this here. P. Exponent and power are the same thing. My handwriting is bad on my laptop, so it's not going to be easy. Yeah, anyways, it's going to be the same. Okay, going to be the same. This is what even makes an exponent here. This is what makes an exponent. Without this main x here, it will not make an exponent. Okay, it will not make an exponent. Okay, moving forward. Now we have a few laws for the exponents. So I'll go slowly. Let's start. Okay, this is red. So let's take a different color, like blue. Now let's start with the first law. So whenever you have the same base, but you have different exponents or powers, and you're trying to multiply them, okay, you're trying to multiply them. You're trying to multiply them, dot is just equal to multiply. Okay, so this meaning you can add the both terms since the base is the same. As you can see, it's x and x, so you can put it x power m plus n. Okay, you put it to x power m plus n. Okay, let's use this with this short example, shall we? If you look up onto the right, I have 2 power 2. I'm going to take the same example, dot 2 power 3. And now I'm going to take it different. I have 2 power 2, but instead of 2, let's keep it as 3 power 3. So which would satisfy this? Which would satisfy this? You know what I've already told. Yeah, see here, if you look here, it needs to have the same base. It has to have an exponent. Sorry, my bad. It has to have a base and an exponent. As to contain exponent, it should have an equal base. The general formula. With knowing this, with knowing this, how are you gonna solve this? Okay, so we'll keep this as 1 and you'll keep this as 2. Okay, now let's, if we look up on the left side, let's start solving. So 2 power 2, instead of dot we put times 2 power 3. Now, if you look up to the formula here, you have x and x. Is it the same base? Yes. Do we? What about here? 2, 2, same base, right? So let's keep x as 2. And we'll keep the 2, the power, as m, and the 3 as a power n. We'll keep as variables. Now since we put x as 2 for the base, let's keep it as x. What do we have for 2 for the exponent or power? M. Same way we do for n. So we have 3 as n, so it's x power n. Now, if you look up to the formula here, x will be equal to m plus n. So you have m here, you have n here. So it's going to be x power n, m plus n. What is this going to be simply? Now if you take out everything, if you start substituting again, you're going to end up with 2 power m plus n. What's m? 2. What's n? 3. So it's going to be simply 2 power 5, which is simply is just 32. So that's the first answer, 32. Okay, so first answer, which is 32. See, I hope you understood. I'm explaining as I'm explaining the best I can. I can't do much. Okay, sorry. I do better honestly if I was on a whiteboard. It's much more simpler, but then I can't because I don't have a camera with me. Moving on to the second question. Now let's focus on this. So you have 2 power 2 times 3 power 3. Let's do the same for this. How we did for this, we need to find if the base is the same. Let's not worry about the exponents here. Okay, let's just get rid of all this. Let's not worry about the exponents up here. I need a better highlighter. One sec. Let's take a different color. Let's not worry about, whoa, it's not good. One sec. Let's take like much more lighter color like this. Hopefully you can still see it. So this is supposed to be green. Why is it? Okay, whatever. It's okay. Sorry, let's not worry about the exponents. Now let's focus on this. The powers. Bro, why is it invisible? Let's focus on the. Okay, now it works, huh? Oh my god. That. Now let's focus on the base. Now what base do we have here? We have two, we have three, right? We have two. Not work. Is there an undo button on this? There isn't, but whatever. I guess we just use pen. So we have a two and we have a three. So this here meaning this is two and this is three. Now, does this count as the same base? It doesn't, because a completely different bases meaning a different numbers. Because from what we have here, it has to contain exponents and might have equal bases. That's most important here. So you can't use any of this here actually. So what you're gonna do is just do it manually like this. That's the answer here. Just so this will not follow the first formula here. Okay, it will not follow the first formula. It will not follow this. Oh, the this here will not follow the first equation. So this is not a law of exponent. Okay, hope you have understood it. I explained as much as possible, and I honestly took the same too much time for that. Well, that's just one out of five. Let's go much faster. Okay, so from third, okay, let's go second. It's easier. Now you have x whole power m. So you have x, you have y whole power m. What does this do? If you want to expand it, I mean, most of you should be knowing that. That's why I'm only explaining this again. X to the power of m and y to the power of m. This is the main thing which is used everywhere. This is used every single area. This will be used in questions or anywhere else. You have to be knowing this. Okay. So this is pretty simple. So if you have, let's say you have x, y to the power of 3. This is going to be x cubed y cubed. That's the answer for this. It's pretty simple. If you just expand it, if you expand this, just remember this. Okay, just remember this. Because it's a whole bracketed, right? It's whole bracketed. So that's why you just take the 3 for both each. It works the same way for numbers too. It works for everything. Letters and numbers both. Okay, let's go for third. You have x power m to the whole power n. So you have x here, you have m here, n here, right? Okay, let's take a small example, shall we? Keep x as 2, m as 3, and then n as 2. Okay, now what we're gonna do, okay, now put this. 2 power 3 is 8, and then 8 square is 64. Now let's do the same way on the side. If you look on the right side, that is, okay. Now this is the formula. So whenever you have this, these two, instead of coming together like the second one, they'll start multiplying as m times n, which is just basically mn. So same way here. 3 times 2, okay, times 2 is 6. Now what's 2 power 6? We know 2 power 5 is 32. So 2 power 6 is obviously going to be 32 times 2, 64. Look at the amount of steps we did here, and look what happened here. See what I mean? Look at the difference here. Look at the difference. Look at the difference. How it's both different. Okay, just know that. Now moving on. This is the same way. If you see here, these two are related. So I don't think I need to do explain for this. Okay. So this answer here is just pretty simple. Okay. I'm not gonna really go into explaining that because you should be knowing it. Now, when you have a division, this is just gonna be this. Cause here m is greater than n, and m is greater than n, you have to do this. But if at all it's ulta, okay, vice versa, meaning see, just wait. It's like this because n here is greater than m. N is greater than m. It's completely different. These are both completely different. Okay. See, there's one more way here. Okay, wait, let me show you. Let's get rid of all this. See, there's one more way. See, you can still use it by doing this here, but instead keep it like this. Suppose, let's say that this is equal to y. Okay, so it just becomes the power of minus y. You come to negative exponents when we do, but I'll just say now. So whenever you have a negative exponent, what you do is put it, this comes to the power of 1 with that power in the denominator. So then it's normal, but it is because of the 1 here. Okay, that's it. Yeah, that's it here. So this is all for the laws of exponents. Coming into a few basic exam. Coming to this fractional index. Oh my god. So I do not follow this, okay? Do not follow this. Do not follow that. Let me do this. Let me do something. I'm gonna cover all this up. Do not focus on this right now, okay? Do not focus on this right now. Focus on me. Eyes on me. I mean, you can't put your eyes on me because I can't. So whatever. So, okay. So, what we're gonna do now? We take root of a random variable. Okay, let's say with a letter, it's gonna come out to 1 by 2. Remember, when you're always using square root, your power will be always to the power of half. But if you're using a cube root, this changes it. This comes to 1/3. Okay, just remember this and remember this here. Square root. Since it's square root, remember as 2. Remember, this is cube root, so it comes as 3. No, put that in the denominator. Now, what here? This is also 1. Okay, this is also 1. So, this comes to the numerator. Right? Okay, let me give a different example now. Don't focus there. Don't focus on that formula there. Suppose I give this now. Take a square root of x square. What is it going to be? What is it going to be? X square half. It will just be x to the power of 2 times 1 by 2. So just x. Just x. Wrong. Do not do it like that. Do not do it like that. Let me show you. Let me show you. It's related to this, so focus. Focus on me. Focus on me. Now, because here it's still a square root, it's obviously going to be 1 by 2. It's obviously going to be 1 by 2. Am I correct? Okay. So, as you can see here, the denominator will be n, the numerator will be m in this equation. So this is the numerator, denominator. The denominator, your numerator. So like I told, it's going to be x for 1 by 2. Why? Because look here, m is your power here. M is a power here, right? If you look at the denominator, it defines the classic exponential power. But if you look at n, it defines the index of the radical root. Meaning, if it's like a square root, a cube root, if it's a root of 4, a root of 5, and so on. Simply here, just do this. Let's change this to 3. I want anything complicated. So since this is here, keep it in the bottom. Whatever is outside the root, bottom. Whatever is inside, on the top. Remember like this. Inside important, so inside will be top. Outside not that important, so outside bottom. Okay, remember like that. So this is your correct power instead. This is the correct power. Now if this was 2, yes, it would be x. Yeah, so yes, I was correct. I was just joking. Yeah, no, I was just joking. I was playing with you. It'd be like this. Let me show you why. This is a 2 here. I mean, usually it's not that, I'm just writing it, okay? Don't do actually the exam. So 2 is 1. So now, see, wait, 1 second. So get rid of all this. Okay, now focus here. Now, see. This you can do. You can do this because why? Look at this. Cancels. It's just x. It's just x. And that's actually the correct answer because it's a square root, remember? And you're exactly the power of 2. So it's obviously going to cancel. Am I right? Okay, now let me show you another example. Okay, let me show you next. Okay, this also works the same way with cube root. That's why we have this entire formula here. Okay, now let's take the same example but differently. It's gonna be this. So what's gonna be multiplied? You get just x to the power 2 by 3. So this 3 in the bottom represents as a cube root. If there's a 2, it represents as a square root. If it's 4, it's root of 4, and so on. So that's why, remember like this, n by m. Let me actually more there. Remember it as x to the power n divided by m will be always the answer to this. You can see here. Yeah? Okay, remember it like that. Okay, now coming to the next property. Let's see how much time I have left. Don't know. Come on. Okay, we went by for 34 minutes. We have half an hour left. Okay, take a break, refresh yourself, and we'll be back after short and take a break, refresh, we'll be back after a short intermission. Okay, see you next. Okay, let's continue now. Let's continue. Now, moving on to the next. Now, whenever, if you have anything to the power of, sorry, I didn't see that. Okay, if you have anything to the power of zero, note it's always going to be one. Whether it's an actual number or whether it's an actual variable, it's always going to point to one. So, yes, it does cancel it out. So, this is pretty simple, right? Next, you have anything with the power of negative 1. Like I explained it way before slides, it's going to be power 1 by x. Remember like this. So you have that 1 here. No. You have this negative, it's like a 1 no. Goes here. Remember that. Now, whatever power you have here, keep it as it is. Now, suppose we have this. It's going to be 1 by, because of this it's going to be 1. Remember, as it as like 1, because it's not a bit, it's just vertical. Okay, and then that, see that, right? Okay, now anything to the, oh sorry, my bad. So anything to the power of 1, anything to the power of 1 will always be the same. Suppose you have 3 power 1, it's going to be 3. But if you have 8 power 1, it's going to be, it does not cancel like this. But if you have something like this, just note that's going to be the same, because it's just 2 power 1 and x power 1. Okay,
Okay.
okay, moving forward, here are a few basic examples. Okay, try to understand. I'm not going to explain this because I've explained everything you need to know now. Okay, you can just pause the video here. You just see this. Okay, I'll show this again. You clip it, pause it, do anything, just learn it. Please learn it. If you don't understand it, come to my Discord server, ask for help in the help chat, or you can just ping me anywhere, ping me. Okay, I'll come. Okay, I'll come. Now for the test, I'm not gonna do the test now because we're running out of time. I'm gonna move to negative exponents. Okay, I already explained this, but I'll just say it again. A negative exponent indicates a reciprocal. Okay, it indicates a reciprocal, not a negative value. Okay, it tells you to flip the base into the a denominator. So now you want to transform this 4 to the power of minus 3. So step 1 is to identify the negative sign as a reciprocal instruction. So you have 4 to the power of minus 3. Reciprocate. Put the base in the denominator. So it becomes 1 by 4 power 3 or 4 cube. So next, drop the negative sign and move the term to the bottom of a fraction. What we did right, that will be this. So that will be this. Okay, next, calculate the remaining positive power, and then you'll end up with this. Or you can end up, which is basically this. Okay, moving on, we have scientific notations. So this is called standard form. It's called standard form. It will be like a number into the power of anything, including negative powers. Okay. So let's say we have 45000 like this. So the massive value, just shift the decimal point to the left. Remember, it has to be only two one value here. I mean 1, 2, 3, but it has to be to only one decimal point because you want the zeros to be removed. And the same way you can just do for this two here. So I'm not gonna go really much into it. If you didn't understand, again, come to me. Okay? Or you can just look at a YouTube video about this. You can flip this. You can try to understand this. You can also pause the video. Moving on to equations, like I already explained in the last video. So, yeah. Firstly, what is an equation? So, an equation is a statement that two expressions are equal using the equal sign. Now, this, if you can see, is very important. This is a main thing when you come to this. This will be the main thing for an equation. Okay? Equation. So why you want to learn equations? So equation will help you like solve problems to find any unknown values in an equation or in normal areas. But they're used in various areas like science, engineering, economics, and other daily activities. So these equations will help develop your thinking skills. So it'll like improve them this way. So I've already explained this in the last video. If you didn't know, I'm not gonna go into this now. Okay, let's solve the homework problem. This was a homework problem. So let's solve it. So 5x minus 4 is 11. Shift the 4 with the sign on the side becomes plus. It's just 5x equal to 15. X is equal to 3. This is the correct answer. See here? It's equal to 3. Now, next. Okay, here the practice problem. You have x square plus 3x minus 4. Use that method ready to multiply a and c, which is x square and minus 4. You get minus 4 x square. 4 and 1. It's positive, negative. So this. No, this way. No. This negative. Okay, then just x square plus 4x x minus 4. So it's just x plus 4, and then x plus 4. Wait, let me check. Minus x. Oh shit, no, wait. See, I made a mistake here. It's a 1. Because I removed the x, it becomes 1. Oh, sorry, it's x only. No. Remove the x there. Instead of that, you just put a 1. So it becomes minus x minus 4 again. So you end up with this. Is this the end? No, it's just to find the values of x here. So this is still equated to 0. So then x is just minus 4, 1. How did I get this? Since this is still equated to 0, just equate both to 0. Done. So your answer is just look. Yep, correct. This, hey, wait 1 second. I think there's something. You see that? Yeah, look there. Look. Yeah, there's something there in the black. It's fine. Well, this is the 7 takeaways. You can try this by yourself. I'm not solving this, okay? I'll just display the answers. 4x is 4, x is 2, x is 3. Answers to the following questions there. Okay, so that's it for laws of exponents. Okay, so that's it for laws of exponents. Oh, finally it's finished. So I hope you liked the video today. If there's any doubts, just come join the Discord server again today. Okay, we'll be back after be back once again after started intermission. Okay. Well, this is it for this video. I guess actually. Well, I hope you liked and I hope you liked the video. Please like and subscribe. Join my Discord server. It's going to be up on the channel description or other videos description. Yeah, I posted the link on the last live, so you can just look at it there. Well, I hope you liked the video. Okay, and whoever birthday it is, happy birthday. Yeah. Okay, happy birthday. Okay. Anyways, I'll see you next time on another video. Okay. Yeah, I hope you like and enjoyed this video. Please subscribe, join my Discord server, and we'll meet you next time, shall we? So this is it for this video, guys. Okay. Bye bye. I'm out.